All right, class. Let's see. This is calculus homework. This is Appendix E. The questions that we had was 9, 33, and 43 from class. Let's go for it. So this is number 30 or number 9. Oh, sorry, number 9 is as j goes from 0 to n minus 1. Formula for it. There it is. And so notice because if it's an n minus 1, we're not going to really get to the answer. Like we're not going to get a value of 12 or something like that. But we just want to write it out in expanded form. So let's go for it. So as j is equal to 0, we got ourselves negative 1 to the 0 power. Then we have j is equal to 1. And so for the j values, remember the index values, normally we use I. We could use j. We sometimes, rarely, we will use k sometimes, h, n sometimes. So those are usually the letters that we use for it. In this case, it's just j. That's fine. So we're at the third iteration, which is 2. So it would be negative 1 to the 2 power, and then so on and so forth. We're going to keep doing this until we get to n minus 1. And we don't have a value for n, and that's okay. All right, the only thing is we can simplify this here. So if you take negative 1 to the 0 power, it just becomes a positive 1. Take negative 1 to an odd power, you're going to get minus 1. It's interesting. Notice if you take it to the second power, you get a plus 1. And then if it was even to the third power, you get a minus 1. So notice that's an interesting setup there. So each pair of 1s actually give you a 0. And then you can keep on going. You could just put dot, dot, dot at this point. Normally we put a dot, dot, dot after the plus sign, right? Because you can add negatives, you can add positives. So normally a plus sign would be the sign in between the dots. And then we get to the end, which we don't know what this is, which you'll leave it as negative 1 to the n minus 1. That is it. That is number 9. All right, moving on to number 33, I think is a long one here. So let's go with it here. So this is I is equal to 1 going up to n. And we have ourselves I plus 1, I plus 2. And we're just trying to find the value of this. So let's go for it here. So what I would probably do, I would just multiply the I plus 1 times an I plus 2 out. So I is equal to 1 still, goes to n. Then we got I times I is I squared. Then we have ourselves, technically it's I times 2 and then 1 times I. That one and that one. And that gets me 3i. And at the end, you got a plus 2. Oh, you know, that should have been a plus 2, not plus 3. Right there. I made a little mistake there. That should be a plus 2. I think I'm going to correct it later. So let's go with it. So that means we have this. We have that. And there's my 2 now. I put that in there. Okay, so that should have been a 2 right here. All right, and so notice what I did is I distributed the sum symbol into each of these here pieces. So yes, you can what you can also do is you can take the so you can distribute among plus or minus the sum pieces. You can also take a multiplier. You can stick it out in front. It's just a multiplier of 3. So that's what I'm going to do next here. I'm going to take this 3, put it out in front. So here's my iteration of it. Technically is I squared plus 3 square root of that I plus that. Okay, now we know the formula for I squared is n times n plus 1 times 2n plus 1, all divided by 6. That's the formula for I squared. We have a 3 multiplying the I formula. The I formula is n times n plus 1 divided by 2. And then if you have a constant, in this case it's 2, what would be the end result of that? Would just be a 2n. All right, there it is. I'm missing that little parenthesis right there. Kind of finished up that parenthesis there. Okay, so let's go with it here. So I'm going to distribute, looks like, yeah, I'm going to multiply the n plus 1 and the 2n plus 1. Let me do that. So n times 2n makes 2n squared. Then I got n times 1 and a 2n make a 3n plus 1. And this one's going to be n times n and n times 1. That's easy enough. And I got my 2n at the end. Okay, so now let's go with it here. I'm going to multiply, now I'm going to multiply the n into here. So n times that, n times that, n times that all over 6. Here I'm going to multiply the 3n. So 3 times that and 3 times that over 2 and plus the 2n. The only thing we got to do here is just to simplify this out. So a lot of simplification, but let's go for it. I'm going to first of all divide out that 6 into each one of these pieces. So if I divide into that, right, 6 and 2 would reduce down to 1 and 3. If I divide the 6 and 3, that would just make a 3 divided by, that's about 2, and then that would be n over 6. Okay, cool, that's easy enough. Then we got the 2 here. 2 does not go into 3, so I'm going to write it like that. And then I'm going to write this one again. 2 does not go into 3, write it like that, and then we got the 2n at the end. Okay, so now I have to collect all these pieces together. As I'm collecting these pieces, what I'm going to do is I'm going to get common denominators. So notice I have an n to the third power. That's the only one there. So let me just give it as n to the third power. Now let's see our n squares. Oh, they both have a 2. Our n squares, both n to the second power, both have a denominator of 2. So that's nice. So that's just going to be there. So that's 1n squared plus 3n squared makes 4n squares. I'll simplify that in just a bit here. So now my n's, oh, my n's are interesting. So that means that's my n over 6. I have to get common denominators now of, let's see, common denominator 6. That make a 9n on top. And then this one also. This one has to be a denominator of 6. So that'd be a 6 over on the bottom of a 12n. Okay, now let's put this together. So n to the third power of 3. That reduces down to a 2n squared. That's cool. This is all over 6. So let's see. That's 12 times plus 9 is 21. 21 plus another n makes 22. And 22 over 6, that should give us an 11n over 3. Hopefully we can do that in our heads. Okay, so here it is. Technically, this would be a simplified form. Okay, this would be a correct, and nothing wrong with this here. Normally, though, also in calculus, what we do is we put it into factored form. If we can factor stuff out, we like to do that. So now, if you did this on a test, this would be correct on test at this point if you stop here. The other simplified form is factored form. So notice you have all of them have denominators of 3 except for the middle. So let's make a denominator of 3 for the middle. So if there was a denominator of 3 in the middle, that means the 2 would have been a 6 here. So let's do that here. So I got 6n squared over 3, and then I got this guy here. So now I'm going to do is I'm going to factor out whatever I can. So notice all of them have n's inside them, so I'm going to take out an n. All of them have 3 inside them. I'm going to take out a 3, and the leftovers are going to be n squared plus, so that the bottom 3 comes out, but we still have a 6n squared there. And then let's see, you got an n taken out from the n squared. Yep, that's cool. That works. And then the 3 went out, the n came out, so just 11. That's all I have there, and I'm good. Okay, and last one. Here it is. The limit as n goes to infinity of that right here. All right, and hopefully this is familiar to you. There should be a little familiarity to this. Like, I think I've seen this before. If you have already done this, the extra lecture for 5.1. So let's go for it here. So if it does not have an I inside it, it does not need to be inside the summation formula. So I have limit as n goes to infinity. I can pull out the n 1 over n outside already. I'm going to simplify this. So it goes I squared over n squared. Next, I can pull out the n squared. So let me pull out the n squared that's on the bottom. So I got n to the third power summation of I from 1 to n of I squared. And I have a formula for that. All right, formula for that is let's see, got 1 over n squared, multiply n plus 1, 2n plus 1 over 6. Let's simplify this as much as possible. I think the first thing we can do is notice that we have the n to the third power on the bottom. It's supposed to be a 3 right over there. Then we just have an n on top, so I think I can cancel the n cubed on the bottom and the n on top just a little bit here. So I got myself limit as n goes to infinity of, now it's 1 over n multiplying out n plus 1 times 2n plus 1 over 6. All right, so now let's multiply this out. I'm going to go n times 2n and just multiply everything out right over here. So I got myself n times 2n is 2n squared, n times 1, and then 1 times 2n makes 3n, and then 1 times 1 is 1. On the bottom, I have a 6n squared. All right, at this point, you can kind of tell, like, oh, what's going to be the limit as n goes to infinity? You can do it the arithmetic way of doing it. You can divide each of these pieces. This I'm going to do here. I'm going to divide each of the pieces by 6n squared. That's another way of doing it. So the 6n squared goes into each one of those, and let's see what happens. So go back just for a second here. Boom. So the first one, n squares cancel. 2/3 make a 2 6 makes a 1/3. So 1/3. This becomes now 1 over 2n, and this is going to become 1 over 6n squared. Okay, so then remember, as limit goes to infinity of something on the bottom of a number in the denominator, that means that guy's going to go to 0. So 1/3 stays. As the denominator gets bigger and bigger and bigger, 1 over 2n is going to become closer and closer to 0. So same for the other piece, and then we get ourselves a 1/3. And so there is the answer to that one. Hopefully that was useful to you guys.